Well, we've been talking about the shapes of molecules, and talking about the shapes of molecules, sometimes in quite an abstract way, talking about molecules that we never really come across before and we'll never come across again, like BRF3. So I want to put it into a bit of context. So these are the shape changes that occur during actual reactions that we're some familiar with, some not quite so familiar with at the moment. And also these kind of questions do come up in the exam, so it's not just for the fun of it, that is useful for the exam. Okay, so let's have a look at this reaction. We've got ammonia reacting, dissolve it in water, and it's an equilibrium reaction. You get the NH4 plus ion, the ammonium ion, and the hydroxide ion. Of course, that's going to make it an alkaline solution. Here, the NH3 is acting as a base because it accepts a proton. The water is strangely acting actually as an acid because it gives away a proton to there. So that's what's going on there. But let's have a look at the shapes of what's going on here. So, well, we have got ammonia here, and that is three bond pairs and one lone pair. So the basic shape is tetrahedral, but we've got a lone pair on top there. So it's going to be, I draw it, it's going to be, I'll try and move this thing down as well, I think. Out of the way a bit. So it's going to be, you've got your hydrogens there, and you've got a lone pair there. That's going to make the bond angle a little bit smaller than it should be, so that's going to be 107.5. We've got water there. Water it's got four pairs, so it's got two lone pairs and two bond pairs, and that is going to be, it's going to be a bent shape. Okay, so I draw it like you've got like the ammonia. I've got one lone pair there, one lone pair there, and you are going to have a bond angle of 104.5. Let's see what happens to those bond angles after we've reacted then. So after the reaction, the nitrogen here has now got four bond pairs. It doesn't have any lone pairs. So try and keep my color scheme consistent here. Four bond pairs. So we're going to have a tetrahedral. It's going to be the same shape as ammonia, as methane. Yeah. Okay, that's that one, and it will be exactly 109.5 now, that bond. No lone pairs to distort it. And of course, you can't talk about a bond angle there, because for a bond angle for the OH minus ion, you need at least three elements to it, don't you, to have an angle between them. So you can't talk about the bond angle there. So what happens in that reaction then? The ammonia goes from being trigonal pyramidal to being tetrahedral, and the bond angle goes from 107.5 to 109.5. Right, let's have a look at this one then. Okay, now, so this is a similar reaction. Here what we've got is we've got a water molecule, the black water molecule, reacting with the red one, and you form OH minus, and you form the H3O plus ion. Okay, which of course we know is, in shorthand we write that as the H plus ion. So we want to know the change in shape occurring there. Of course, this reaction, this is the reaction here, this happens in water. It's about 1 in 10 to the 7 molecules will do that. Most water is just H2O. 1 in 10 to the 7 will form these ions. Okay, so we'll do that when we come to acids and bases in year 13. More about that. Okay, so here, well, the shape of the water molecule, we just said in the last one, yeah, it is V-shaped, isn't it? We have two lone pairs to distort it, so the bond angle is going to be 104.5. Now, after the reaction, of course, that one, the OH minus, it doesn't have a shape because it doesn't have an angle because it's only two atoms. But let's look at the H3O plus ion here, okay? What shape is that going to be? Well, we have got 3 bond pairs and 1 lone pair. So there's a basic, it's like the ammonia molecule, isn't it? So you're going to have oxygen, 1 hydrogen coming towards you, 1 going back into the paper, 1 in the plane of the paper, and we've got this lone pair here. So the shape is going to be trigonal pyramidal. And the bond angle will be the same as you find in ammonia, 107.5. So you can see the bond angle changes from 104.5 to 107.5. All of these shapes, the ammonia-like shape, the methane-like shape, the water-like shape, they're the really important ones because they're the ones with 8 electrons in their outer shell. So that's going to be most of the atoms we're dealing with in molecules. Right. This one now is very similar to the one above, but this is with PCl5. So apparently PCl5, if you melt it, it's a covalent compound, so it shouldn't conduct electricity, but it does conduct electricity a little bit because it doesn't all stay as PCl5. What happens is you get this reaction, it's an equilibrium reaction and it's far over to the left, but some of it turns into PCl4 plus and some into Cl minus, PCl6 minus, sorry. So what has happened is that the black one gives away a chloride ion to the red one. So let's see what effect that has on shape then. Okay, I'm going to rub this out, give myself a bit of room. Okay, so here, PCl5, well, you have got, this is a tricky one, isn't it? We've got 5 bond pairs. So this is the one with 2 different bond angles. So you have, remember, we draw it, I like drawing it with a little flat piece of paper there. So you have 3 of the chlorines in the plane there. Then you have 1 down here and 1 up there. The bond angles are 90 degrees and 120 degrees, and that's called bipyramidal. Because you've got like 1 pyramid sticking on top of the blue piece of paper, 1 pyramid stuck underneath the blue piece of paper. Right, after the chloride ion has been exchanged, then here, this has got this PCl4 plus, which is, not something we've come across before, PCl4 plus, but it's quite easy to work out the shape. It's got 4 bond pairs and it's got no lone pairs, so it's going to be tetrahedral. It's going to be like methane shape, tetrahedral. So we're going to have the phosphorus there, 1 chlorine coming out, 1 going back in, 1 in the plane of the paper, 1 sticking up there. It's going to have a positive charge on it. It's going to be tetrahedral. Right, it's getting very messy here, but this one here, well, what have we got? We've got a dated bond there, of course, yeah. And so it's good to revise that a little bit. And we have got 6 bonding pairs and no lone pairs. So the shape there is going to be octahedral. And if you remember, that's where you have, so you're going to have 4 chlorines all in the flat plane. 1 sticking up, 1 sticking down. And all the bond angles are all 90 degrees there. So you've got got 3 different shapes in that reaction. The bipyramidal, the tetrahedral, and the octahedral. Okay, I think I've got a couple more which I couldn't fit on this page, so I put onto another one. This one here. Right. So, which one did I start with? I've got one up here. Oh yeah, this is what ammonia does. Now, ammonia will only do this. This reaction only occurs in liquid ammonia, which I've never seen liquid ammonia. We certainly don't have it in school. but it's very similar to the reaction with water. You get an equilibrium of water reacts with itself to produce the OH minus ion and the H plus ion, or the H3O plus ion. Okay, so it's very similar to that. It happens in liquid ammonia. It's an equilibrium reaction. Most of the ammonia stays as just the covalent ammonia, and a bit of it forms the ions. So I just get rid of this stuff here. Right. Now we can think about the shapes, and these are all pretty familiar, these shapes. Right, ammonia, we've done it in lots of examples before. It is, you've got 3 bond pairs and 1 lone pair, so there's 4 altogether. So the basic shape is tetrahedral. So we're going to have the 3 hydrogens like that, and a lone pair, which squashes the bond angle down to 107.5. This one here we come across before, where there's 4 bond pairs, the NH4 plus ion, and that's going to be tetrahedral. That's the same shape as methane. Okay, that's easy enough. Positive charge on it. And this one here, we've never come across this species before, but NH2 minus, but it's the same shape as water, isn't it? Hopefully you can see that. You've got 2 bond pairs and you've got 2 lone pairs. So, it's 4 altogether. So, put the nitrogen atom there. And there's the 2 hydrogen atoms. There's the 2 lone pairs, squashing that bond angle down into the same as we get for water, 104.5. Okay, then the last example now, nice short one, I'm glad to hear. Right, a little bit different as well. Okay, now this reaction here, covalent aluminium chloride react with the chloride ion to form this here. We'll come across this in year 13 when we're doing about the chemistry of benzene. So if you're revising, you're in 13, you're revising, you probably know what I'm talking about. If not, doesn't matter, we can just look at this reaction in isolation. So we've got aluminium chloride up here. That is one of these funny ones. It hasn't got 8 electrons in that shell, it's only got 6. It's got 3 bond pairs. So it's going to be trigonal planar. All of those atoms are in the same plane. They all fit onto a flat piece of paper, and the bond angle is 120 degrees. Right, once the chloride ion joins up with it, well, now we don't have 3 bond pairs, we have got 4 bond pairs. And so that is going to be the same shape as methane. It's going to be tetrahedral. It's going to have aluminium with the, not H's, are they? The Cl's. By the way, on this example and the previous examples, I haven't put all the electrons on my chlorines because it just takes too long. I'm not being ignorant. I don't think chlorine's only got 1 electron, but it just saves a bit of time. And in each diagram, I've usually put the right number of electrons in one of the chlorines. So please let me off. So that's AlCl4, and the bond angle for that is going to be 109.5. So the bond angle goes from being 120 after it reacts up to 109.5. And that is all the examples I'm going to do there.